Good day. Today we're going to discuss Module 7 of CE 2121, Fundamentals of Surveying. So we are going to cover the topic Missing Data on Traverse Analysis. So to start off, in any field measurements, there are times wherein some measurements of length and directions cannot be performed or cannot be obtained. Thus, we now apply omitted measurements. So the omitted measurements are the missing quantities that may be determined analytically to obtain a complete set of notes for a closed traverse. So this is caused by impracticality or impossibility of any field observations for length and directions. This is applicable if the missing sides do not exceed 2 sides or 2 lines. A disadvantage for using or applying omitted measurements in our field observations and computations is that all possible errors and mistakes are thrown in the computations, and it would now eliminate the checks on the precision of our field measurements, because we are assuming that all measurements we have done are already correct and there are no any errors. So omitted measurements have common types, which includes now the omitted measurements in one side, meaning the length and bearing of one side is unknown. The second is the omitted measurements of two adjacent or adjoining sides. So case 1 is when the length of one side and the bearing of another side is unknown. Second case is that the length of the two sides are unknown. And case 3 is the bearing of two sides are unknown. The last common type for omitted measurements are the omitted measurements of two non-adjacent or non-adjoining sides, which will have the same cases as the second type. So case 1, it's when one side is unknown for the length and the other side has an unknown bearing. Case 2, the sides or the length of the two sides are unknown. And case 3, the bearing of the two sides are unknown. So we begin with the first type, omitted measurements in one side. So length of bearing or length and bearing of one side is unknown. So we use now here the equation for the length of the unknown side as equal to the square root of CD squared plus CL squared, and that the tangent of the alpha is equal to the negative CD all over the negative CL. So L here is the length of the unknown side. CL is the algebraic sum of the latitudes of the known sides. CD is the algebraic sum of the departures of the known sides. And the alpha is the bearing angle of the unknown side with regards to the sign. So for the bearing angle, we will follow the negative signs of the computed CL and CD. So example we have here. So in order to solve for this line EA, then we have to apply these two equations to determine the length and its bearing. So to understand omitted measurements in one side, let's have an example. So from the given tabulated data for a closed traverse, determine the length and bearing of the unknown side or unknown line EA. So for a simple diagram we have here, so the bearings of the lines AB, BC, CD, and DE are known, and also their lengths. So the length of EA and its bearing is unknown. So to solve for our EE, we have to first solve for our latitudes and departures. So as we have learned in traverses, latitudes are computed as the length times the cosine of the bearing. So for EB, we'll have the latitude as, so it's north, so it will be placed here, and that value is 4.45. For BC, it's a southing equal to 3.75. CD is a southing equal to 7.92, and DE is a northing equal to 6.18. Next, we solve for the departure, which is now equal to L times sine of the bearing. So for EB, it's an easting, 5.70. BC is an easting, 6.12. CD is a westing, 2.52. And DE is a westing, 2.54. So once we have computed for the individual latitudes and departures of the known sides or known lines, we now compute for the sum of our latitudes and departures. So for northings, that's 10.63. Southings is 11.67. Departures, easting, we have 11.82. Westing, we have 5.06. So to compute now for EA, we will need to get the algebraic sum of your latitudes. So that is now CL, giving us a value of negative 1.04. And take note that the negative value of CL will be the latitude of the unknown side. So latitude of EA now is 1.04, and it is now positive. So it means EA will have a northing. So next, for the departure sum or algebraic sum of the departure, we have now CD, and it will give us a value of 6.76. Negative value of CD is the departure of EA. So it is now negative 6.76. So the departure of EA is a westing. So, okay. So note, always remember that the negative of the sum or the negative of the algebraic sum of the latitudes and departures of your known sides are the latitude and departures of the unknown side. So we have solved already your latitudes or CL and CD. We can now apply the equation for length as L equal to CL squared plus CD squared. So we will get now the value of the length of EA equal to 6.84 meters. And for the bearing of EA, we apply tangent of alpha is equal to negative CD all over negative CL, or that's latitude of, or that's departure of EA all over latitude of EA. So substituting the computed values, we have now alpha is equal to 81.25. So therefore, the length now of EA is 6.84 meters, north, 81 degrees, 51 minutes west. So if we're going to check our diagram, it is northwest. So the next type of omitted measurements are omitted measurements for two adjacent or adjoining sides. So as we have said, there are three cases for this type. So one side has an unknown length and the other side will have an unknown bearing. Case 2 is when the two lengths of the two sides are unknown. And case 3 is when the bearings of the two sides are unknown. So the analysis for any of the case for two adjacent sides whose data are missing would be the same. So the conventional approach will be to close the traverse by connecting the ends of the two unknown sides. So when we do that, we'll now have a new traverse formed, and this new traverse now formed by the known sides, and a closing line is analyzed as a traverse with one side missing. So once the length and bearing of the closing line is determined, the triangle formed by the two unknown sides and the closing side is considered next. So the length and bearing of the unknown sides may now be solved using geometry and trigonometry, or specifically the sine and cosine laws for your triangles. Okay. So to have a better understanding of missing data on two adjoining or two adjacent sides, let's solve an example. From the given tabulated data for a closed traverse, let us determine the unknown distance or length of DE and the unknown bearing of line EE. So to start off, let us draw a simple sketch of the traverse. And from here, as we have said, the first step is to close our traverse using our known sides. So for this given, we are closing it with points D and point A. So the new traverse now formed, ABCDE, is the first to be analyzed using our latitudes and departures. So solving for our lats and depths, so AB will have a northing 7.92, BC is a northing 4.45, CD is a southing 6.18. So latitude of DA is unknown. And then for departure of AB, we'll have an easting 2.52, BC an easting 5.70, and CD is 2.54 easting. So we analyze now the new traverse as a traverse with one missing side. So with this, we now compute for the sums of latitudes and departures. So for northings, we'll have 12.37. Southings, we have 6.18. Eastings is 10.76. And westings is 0. So we solve for the difference in latitudes. So this one is our correction for latitudes, positive 6.19. And the negative of CL is equal to the latitude of the unknown side, which is DA. So we'll have now latitude of DA is equal to negative 6.19, meaning the latitude is a southing. For the departure, so the difference now, or the algebraic sum of easting and westings, will be the correction departure, which is positive 10.76. And the negative of CD is the departure of the unknown line DA. So the departure of DA is negative 10.76, which is a westing. So if we're going to look at the figure, it is really a southing and westing. So to solve for the length of the unknown distance or closing line DE, we have now Pythagorean theorem. DE closing line is equal to the latitude squared plus departure squared. So substituting the values, we get now the length of closing line DE as 12.41 meters. And for the bearing of closing line DA, we have tangent of departure all over latitude. So we get now a value of south. So south, 60 degrees 5 minutes west. So meaning this angle from the vertical at point D to line DE is 60 degrees 5 minutes. So from this, we now consider the triangle formed by the closing line and the unknown line. So we have triangle AED. So let's call the angles of triangle AED as alpha, and this one is beta, and this one will be angle E. Theta 5 is the bearing of line AE. So with this, using now, or from the diagram, alpha is equal to the bearing of DA. So this angle is equal to the bearing of DA minus the bearing of DE. And we know the bearing of DE. So we can get alpha now as 34 degrees 51 minutes. So once we have solved for alpha, we can now solve for DE and angle E using sine law. So from sine law, we have now the angle E is equal to 81 degrees 31 minutes. And from here, we can say that E is equal to theta 5 plus theta 4. So theta 5 now is equal to 81 degrees 31 minutes minus the computed, or minus the theta 4, which will give us now theta 5 equal to 56 degrees 17 minutes. And therefore, the bearing now of EA is north, 56 degrees 17 minutes west. Okay? And for the distance of DE, or length of DE, sine law again, we now have to solve for your beta. And beta can be computed as 180 minus angle E minus alpha. So that's equal now to 63 degrees 38 minutes, and DE from sine law is equal to 11.24 meters. So next we have example number 3. So from the given data of a closed traverse, we determine the length of side DA, or DE and EA. So this one is case 2, as we have two adjacent sides with the unknown where the length are unknown. So first step, we sketch your traverse. A simple sketch will do. So we could follow the conventional approach by closing this traverse at this point and this point, or we could simply go straight to the latitudes and departures. So solving for AB, BC, and CD, we have the latitude at 7.92 for AB, CD will have 6.18, BC will have 4.45, AB will have 2.52, CD will have a departure of 2.54, and BC will have 5.70. So summing up our latitudes and departures. So note that from the traverse, in order to have a closed traverse, the algebraic sum of the latitudes and departures must be equal to 0. So from here, the sum now for latitudes will be 7.92 plus 4.45 minus 6.18. So it's a south, so minus DE cosine of the angle northing, so plus EA cosine of 56 degrees 17 minutes equal to 0. So we have two unknowns, so this is our first equation. We take the second equation for the sum of the departures, which is now 2.52 plus 5.70 plus 2.54. So it's a westing, so minus DE sine 25, 14. Westing also for EA, so minus EA sine of 56 degrees 17 minutes. So we have two unknowns, two equations. We can now solve it by, so let's simplify first. So we'll have For the first equation, sum of latitudes is 0.905 DE minus 0.55 EA equal to 6.19. For the departures, we'll have 0.426 DE plus 0.832 EA equal to 10.76. So once we have simplified, we can now solve this by elimination or by substitution. So from there, we'll now arrive at the value of DE, which is equal to 11.24 meters, and EA is 7.18 meters. So this is one way to solve for your lengths if you have two sides that are adjacent and they are missing their lengths. But you could also use the conventional way of closing the traverse and then taking the new form traverse and the triangle form. Okay, so let's move to another example. So this one is unknown bearings for two adjacent sides. So this is case 3. So for the given data, we'll now have a formed traverse. So if we're going to use the same solution as example 3, then we'll have to use your identities. So we do not want that. So let's use the conventional method. So let's close our traverse. So we'll be closing it at point C and point E. So we'll now be considering the new traverse AB, CE, A. So this traverse. Okay. So from this, we now solve for your latitudes and departures. So AB will have 7.92, BC is 4.45, EA is 3.98, so our unknown is CE. Okay, so easting for AB is 2.52, BC will have an easting of 5.70, and EA will have a westing of 5.96. So let's solve for the sum. So we have a total of northing 6.35, southing is 0, easting is 8.22, and total westing is 5.96. So again, we have your total of latitudes. Algebraic sum is positive 6.35. So therefore, the negative of CL is equal to the latitude of the unknown closing line CE. So CE now is negative 16.35, and that is a southing. So for the departure, CD is equal to positive 2.26. So therefore, the departure of line CE is negative 2.26, which is a westing. So if we're going to check again our diagram, it is really a south to west line. So from our summations of latitudes and departures, we can now solve for the length and bearing of the closing line CE. So for CE length, so Pythagorean theorem, substituting our computed values for the lots and departures, CE is equal to 16.51 meters. And for the bearing, that is tangent of departure over latitude, and it will give us a bearing of CE, which is equivalent to 2 south, 7 degrees 52 minutes west. So from the triangle now, so we consider now triangle formed by the unknown sides and the closing line. So we'll have CED triangle. So we can now solve for the angles C and D by cosine law. So for this, we now have DE, or DE is known, squared equal to CD squared plus C squared minus 2CD CE cosine of C. So C now is computed as 30 degrees 5 minutes, and from here C is equal to 30 degrees, and we can see from the diagram that C is equal to theta 3 plus the bearing of line CE. So theta 3 is equal to C minus the angles formed by ECD, or this is so this will be theta 3 plus the bearing of CE. Okay, so we'll have now theta 3 as 22 degrees 13 minutes. So this is 30 degrees 5 minutes minus this computed bearing. So next, by cosine law, or before that, so CD now is south, 22 degrees 13 minutes east. So this is theta 3. So this is the bearing of line CD. So next we move for line DE. So still by cosine law, we now solve for this angle D. So we'll have equal to 132 degrees 35 minutes. So from the diagram, we know this is theta 3. So this is also theta 3. This is theta 4. So we can see that 180 minus this angle D and theta 3 will give us theta 4. So theta 4 now is equal to 25 degrees 12 minutes. So the bearing of line DE is south, 25 degrees 12 minutes west. So you could check your answers by using instead the sine law. And then you can also check your answers by placing your bearings here and checking for the sum of latitudes and departures. They should be equal to 0. Okay, so let's move to the next type of omitted measurements. This is the measurements or missing data for two non-adjacent or non-adjoining sides. So we have same cases. Case 1, length of one side is unknown and bearing of adjacent line or of the other line is unknown. B, we have the length of the two sides are unknown, and last case 3, the bearings of the two sides are unknown. So for this one, we'll have almost the same procedure as for when we have two sides that are adjoining or adjacent. We'll only have some additional steps. So for our conventional approach, firstly, we move one side of the traverse with known values to a secondary location which is parallel to its original position or its original location. So if we have two sides that can be moved, then we can do that. So you move these known lines to a secondary position to form a new traverse, or to close a traverse. Okay, so it's like we are neglecting or eliminating your two unknown sides. So from the closed traverse, we now analyze this as a traverse with one side missing. So we compute for the latitude and departures, and then compute for the closing line, same as the step in adjacent sides. And then 4, so once the length and bearing of your closing line is determined, we now consider the triangle formed by your closing line and the two known sides. So for this, we'll also be moving one of the unknown sides in order to form a triangle. So from here, we can now compute for the length or the bearing of the unknown sides by sine law and cosine law, or from geometry and trigonometry. Okay, to have a better understanding of two sides or two missing lines or measurements for non-adjoining sides, let's have an example. So let's determine the unknown length of DE and the unknown bearing of EE using the given tabulated data for a closed traverse. So again, we draw a rough sketch of the given data. So we have unknown CD and unknown bearing of EE. So this is theta 5. Okay. So first step is to close our traverse using our known sides. So we have AB, BC, and DE. So we eliminate the unknown sides by, from here we can move line DE to a secondary position. So they are parallel in order not to change your latitude and departure. So from here, we can close it now at this point 2A. So you could also move line DE at point A, but you'll have a different traverse, but you'll be able to get still the same or almost the same values later on. So you may try this at home. Okay, so once we have moved one of the unknown or one of the known sides to a secondary position, we can now close it to form a new traverse. So this is our new traverse in which we will be using to compute for latitudes and departures. So from here, we have the closing line and one of the unknown lines. So in order to have a triangle form, we also move one of the unknown sides or unknown lines to a secondary position. So from this example, so we can move now this line CD to a secondary position. So we have here now a new triangle form. Okay, so this will be, the shaded area will be the figures we are going to analyze. So let's start first with the closed traverse A, B, C, and this point, let's call it E prime, and the move line DE as DE prime, or still it's DE. So for our latitudes and departures, let's solve. We have AB is 7.92, BC, latitude is 4.45, and then we have DE prime is 10.17, since we know DE. Then we have an unknown AE prime. Mommy, what? So next, we solve for the departures. For AB, we have 2.52, BC is 5.70, DE prime is 4.79. So to solve for the length and bearing of the closing line AE prime, we solve for your sums. So northing, we have 12.37, southing is 10.17, easting is 8.22, and westing is 4.79. So we can compute now for the latitude and departure of line AE prime. So for latitudes, so we have positive 2.2, or the latitude of AE prime is negative 2.2, or a southing. And then for the departure, CD will have positive 3.43. So therefore, the departure of line AE prime is negative 3.43, which is a westing. So from here, we can now solve for the length and bearing of AE prime. So for our lengths of EE prime, we'll have now 4.07 meters. So for the bearing, we'll have south 57 degrees 19 minutes west. So after computing for the length and bearing of the closing line, we again consider the triangle formed by the closing line and your unknown sides. So we'll have here A, E, E prime. Okay, so from here, we know your sides, EE prime and AE. So we could solve for the angles at alpha and angle beta. So beta is the angle between AE and EE prime. Okay, so from there, alpha now, as we can see, is equal to the bearing of line AE prime the closing line and bearing of, or this is theta 3. So yes, this is theta 3. Okay, so alpha now is equal to 79 degrees 40 minutes. And then for beta, this is now equal to the angle theta 5 minus, that's minus the bearing of line CD. But since we do not know line theta 5 or the angle theta 5, so we move on first to compute for the length of CD by cosine law. So by cosine law, we have now AE squared is equal to AE prime squared plus CD squared, this is CD, so minus 2AE prime CD cosine of alpha. So from here, we can solve for CD as 6.68 meters. And then to solve now for beta, we compute it by cosine law, or you could also use your sine law. So by cosine law, this will now be AE prime squared equal to AE squared plus CD squared minus 2AE CD cosine of beta. So beta now will be computed as 33 degrees 57 minutes. So from beta, we can now compute for theta 5. So beta is equal to theta 5 minus theta 3. Or theta 5 now is 56.18 degrees or 56 degrees 18 minutes. So the bearing now of line AE is north 56 degrees 18 minutes west. So that's how we solve for your unknown length and unknown bearing. Okay, let's have another example. So given the tabulated data for a closed traverse, determine the unknown lengths of BC and EA. So this is case 2. Two unknown lengths for non-adjacent or non-adjoining sides. So again, we have our simple diagram. So from the figure, we can move line AB to either point C or point E. So you can choose. For me, I'll be choosing point C. So I'll be closing it at this point and line E. So let's call this point A prime. So I'll be forming now the traverse A prime, C, D, E, A prime. So from here, what we can do, so this one is already moved. So the triangle form is EA, EA prime, and line BC. So this will be the triangle formed by the two missing sides and your closing line. So from here, we start off again with the latitude and departures by the traverse form. So we'll have AB 7.92, CD is 6.18, DE is 10.16. So AE is unknown. So we move on to the departure. AB is 2.52. CD is 2.54 and DE is 4.79. So let's solve for the sums. Northing is 7.92, southing is 16.34, easting 5.06, and total westing is 4.79. So for line AE prime or EA prime, we'll have now CL is negative 8.42, or the latitude of A prime E is 8.42 north. And then we have for the departure is positive 0.27, or the departure of the closing line A prime E is 0.27 west. So from here, we can now compute for the length and bearing of closing line A prime E. So for the length, we have 8.42, and the bearing now is north 1 degree 50 minutes west. So once we have solved for the closing line, we can now analyze the triangle form. So we have triangle AE, A prime, E. So with this, we have this line known, or no, we have this line known, unknown length. So we could solve now for angles E formed by the triangle. So that will be theta 5 minus the bearing of EE, or EA prime. So angle E now is equal to 54 degrees 27 minutes, and for angle A, that is now equal to the bearing of BC and the bearing of EA. So angle A now is 71 degrees 42 minutes. So for A prime, that is equal to, or angle at A prime, that is equal to theta 2. So this one is theta 2, or this is theta 2, plus the bearing of EE. So we'll get 53 degrees 51 minutes. So once we have solved for all the angles, we can now solve for the length by sine law. So we'll have BC is 7.22 meters and EA is 7. So for our last example, determine the unknown bearings of line BC and DE given the tabulated data for a closed traverse. So let's have here our rough sketch. So from the sketch, what we can move is line CD. So you can move it at either points B or point E. So for me, I'll be moving it at point B. So I'll have the closing line at A prime E. So the new traverse that we'll be analyzing is this traverse, this shaded portion. And from this diagram also, we can see that the missing side that we can move is line BC. So we'll have here your triangle form. So this will be the figures we're going to analyze. Okay, so let's start first with the closed traverse for our latitudes and departures. So AB 7.92, CD is 6.18 negative, and EA is 3.98. So for the departure of AB, we have 2.52, CD is positive 2.54, and EE is negative 5.96. So our unknown is the closing line, EA prime. So let's solve for the sums. Northing 11.9, southing 6.18, easting 5.06, and westing is 5.96. So from here, we'll be able to compute for the latitude of A prime E, which is 5.72 south, and the departure of line A prime E is 0.9 east. Okay, so from here we can now solve for the length and the bearing of line, or the closing line A prime E. So the length is 5.79 and the bearing is south 8 degrees 57 minutes east. So once you have solved for the closing line, again we move on to the triangle formed by the two unknown sides and your closing line. So this figure will be DE A prime.
So with this, we can now solve for the angles D. So angle D and angle E. So we use cosine laws since we know the sides. So we'll have for D, that is A prime E squared equal to BC plus DE minus 2BC DE cosine of D. So we'll be able to get the value of D as 26 degrees 47 minutes. So from here, we'll be able to get now, or from the figure, DE plus theta 4 is equal to the bearing of BC, angle of the bearing for BC. But since we do not know theta 2 and theta 4, we still need one more value. So we get now the value of cosine, or the value of E for our value by cosine law. So cosine E now will give us a value of 34 degrees 15 minutes. So with that, E, so this angle E is equal now to the bearing of AE prime minus or plus theta 4. Okay, so we'll have now E is equal to theta 4 plus bearing of AE, E prime E. So theta 4 now is equal to 25 degrees 18 minutes. And the bearing now for line DE is south 25 degrees 18 minutes west. So as we have said, theta 2 is equal to D plus theta 4, and that will give us now a bearing for BC, which is north 52 degrees 5 minutes east. Okay, so thank you for listening. For your references, you can visit this site, or if you have the book by Laput, you can use it. So for your evaluate activities, using the computed values in example 7, check for any error of closure and apply necessary corrections, and compute for the area by either DPD or DMD. We choose only one method for your activity. And then number 2, given the following tabulated data for a closed traverse, determine all unknowns and also compute for the area of the traverse. So don't forget to apply corrections if necessary.